In this section, we're going to discuss abstract classes. An abstract class has the characteristic of the abstract keyword somewhere in it. The class can never be instantiated. The idea is that since an abstract method has no definition, at runtime, if such a method were called, there would be no behavior defined. Results would be unpredictable. Often an abstract method is used in an inheritance hierarchy to define specific behaviors that subclasses should perform, much like an interface would, although this is inherited. When a subclass implements all of the abstract methods, it is considered a concrete class. It has substance. It can be instantiated. The book's example is that of the geometric object class. It has such methods as getArea, which cannot be implemented generically because each object type, circle, triangle, rectangle, would have a different computational method. All of them can have the behavior of computing the area. The abstract class often provides an organizational view of an inheritance hierarchy or part of it. Subclasses are treated as the superclass, as would be normal, although in this case the superclass is abstract. We can have collections of such objects. Back to the geometric object, we could have a collection of shapes that we're going to compute the areas for each. When a concrete class implements the abstract method, it, in a sense, overrides that abstract specification. Consider it similar to polymorphism in the sense that it provides a different implementation, although technically the abstract definition has no implementation. So clearly, an implementation is different than that. Client code would see each subclass as an instance of that abstract superclass because they're in a is-a relationship. We can invoke the superclass defined methods on the subclasses and get a behavior that allows the abstract classes to have a consistent interface or a face, what it looks like, and the client code sees them all as similar or nearly equivalent objects. A few points. If any class has at least one abstract method, that class itself is abstract. Any class inheriting from it must implement those methods, or the inheriting class becomes abstract because at least one would not have an implementation. A class can be marked as abstract even though it has no abstract methods. Usually that's considered a marker class for defining specific behavior, but where the methods may have a default implementation, yet the one marked as abstract should not be instantiated. The abstract class can be used in collections, as was noted earlier, allowing all of the entities in that collection to behave like the abstract class, and because they're concrete classes, they would indeed have method behavior defined.